Hey guys, so in this video we're going to go over IXL sections L.4 and L.5. Both of these sections cover the same concept, so we're actually going to work on problems from both sections, and you're going to realize that there's not a big difference between them. So make sure you do both of them. It's just a lot of practice, but it is the same concept. Alright, so I'll go ahead and I'll read this out loud and fill in the blanks. So radicals, also called roots, are simply an operation that seek to group numbers based on repeated multiplication. They are the inverse of an exponent or power, reducing the amount of repeated multiplication that occurs. And we have a diagram, right? And so we see the root symbol right here, right? That is our root symbol. And then we do see this n right here. It's going to play a very important part. So on a radical, the root number, and what do you think it is? Right? And then we can logically go ahead and say, well, that was the root number, so we're going to label this as root number. Determines the size of multiplication groups that are formed. Once a grouping has been made, it is reduced and comes outside of the radical. If there are parts left over that do not fit evenly into a whole group, they are left behind underneath the, and you could probably guess it, right? Left behind underneath the radical. Because remember, these things reduce. So if it doesn't get reduced, well, it doesn't come outside of the radical. It hasn't been done. Since roots look for groups of repeated multiplication, it's often best to break down an expression into its individual multiplying parts, or smallest factors, so that they may be counted and grouped appropriately. Okay, so let's go ahead and look at the steps for this. Try and fill out the blanks before I do. Just challenge yourself on it. Break the expression into its smallest multiplying parts, or, right, what are smallest multiplying parts? Those are factors. Okay, group common factors, creating groups of size blank. So the question here, what size groups do we want to make? Well, remember that is determined by n, right? So that number back up here, n, is what we want to group numbers based on. That's what we want our group size to be on. Reduce complete groupings and write them blank the radical. So remember, this thing is reducing groupings. So if it reduces a grouping, it's going to come outside of the radical because it is calculated, it is done, and whoops, I'm going to put an S in there. Once it comes outside the radical, it's been reduced. It's done, right? That's what this does. So if it comes outside, it's been calculated. Parts that did not fit evenly into a whole group. So, right, imagine we're making a group and we have some leftover parts. Are left behind blank the radical. So let's think about it. If we can't reduce it because it doesn't make a whole group, well, we leave it inside. Because this radical couldn't quite do its job. We didn't have enough parts to make a whole group. Okay? Alright, so let's go ahead and do this. So now, as you get more advanced at this, you're not going to have to write out all of these expressions. You'll start noticing very good patterns. But in the meantime, we'll go ahead and just write this out. So I'm looking to write everything under this radical written out. Okay, so I have 32, and I want to know what the factors of that are, so I'll make a factor tree. And that could be 8 and 4, 2 and 2, and then 8, I know it's just 2, 2, 2. Okay, so I have 5 2's, right? I have a negative 1 right there. Then I'm going to separate 2, 2, 2, 2, 2, 1, 2, 3, 4, 5. So I have 5 2's right there. And then I'm going to have 15 x's. Oof, this will be a lot. If you notice the pattern, don't write it. You can just jump straight to it. But if you're struggling to get the pattern, go ahead and go through writing all these out. So that's 5, 6, 7, 8, 9, 10. And then I'll write them underneath here. 11, 12, 13, 14, 15. Okay? Alright, so that is everything written out. Now, why is it helpful to do this? Because I'm looking to make groups. So now I can go ahead and look for groupings of 5. So I see 5 2's right there. So I'm going to group those together, and on my next step, I'm going to pull that out. So on my next step, I'll start by writing a 2. Because that group of 2's reduced to a single 2, and it's now outside the radical. Now my x's, okay, again, groups of 5, so 1, 2, 3, 4, 5, that's a group of 5. Make another group, 1, 2, 3, 4, 5, that's a second group, and 1, 2, 3, 4, 5, I have a third group. So outside of here, I should be writing 3 x's because I had 3 groups. Okay? And now you may be wondering what happens to this negative 1. Well, the thing about negative 1, anytime we take the a odd power root of it, the negative 1 can actually just come out. So when we have a root 5, the negative 1 can actually just kind of come out of there. The reason for that is because negative 1 can multiply an odd number of times to make itself. So if that's confusing, or you want to know more about that, play with it on the side. That's not what we're here to talk about, but just what you need to know is if you have a odd root and you have negative 1, it will come out of the root. So times negative 1. Okay, and notice, right, that could come out, our 2's came out, our x's came out, and we're left with nothing else underneath the root. And that will happen sometimes. Everything can group very nicely together. It's like having a division problem where you have no remainders. So this is our answer right here. We can make it look a little bit nicer. So we're going to go ahead and write equals. And so I can write negative 2, putting the negative on the 2. And I have 3 x's, so I'm going to write that as x cubed. Right, make it look very nice. Okay, so that's my final answer. Okay, so same deal as before. Just to help us out until we really start noticing what patterns are going on here, we want to write out all of those x's. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, 14 x's, right? So what we're going to do is we now want to go ahead and group them based on the root number. What is that? Well, it's 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And, oh, I can't make 3 with this last one, right? Remember, the group size should have been 3. I only have 2. And this is very similar to dividing. And when you have remainders or things left over, you just can't make a group out of it. You're going to end up not being able to do anything with it. So what we're going to do is we can now start reducing our group. So we have a x that made a group, we have another x that made another group, and another one, and actually we had 4 groups total. And now what about those 2 x's that couldn't make a group? Well, can't make a group, can't come outside. That's the rule. So that's what we get. And we can make this look prettier. We're going to go ahead and we have 4 x's, so x to the 4th. Right, you look very fancy, you know what you're doing. And inside of here, we can write x squared. Bada bing, bada boom. Okay, same deal with this one. Now, as you start to do this, I want you to think, we're looking for groups of 5. So if you had 20 x's, how many groups of 5 could you make? And likewise, we're looking for groups of y, and if we have 5 y's, how many groups of 5 could you make? Right? If you can answer that question, you don't have to do all this work I'm about to do. But this underlying method is the core of what's operating. So, again, same deal. Oof, gonna have a lot of stuff, so make this very big. 1, 2, 3, 4, 5, and I'm gonna kind of group these together, right? 1, 2, 3, 4, 5. That would make 10. 1, 2, 3, 4, 5. 15, 1, 2, 3, 4, 5, and then we have our y's, 1, 2, 3, 4, 5. Okay, so that's representing all of them, and you're going to notice, right? Well, when we have 20 x's, we can evenly group all of them into groups of 5. We just get 4 groups, right? And, maybe you realize this, or maybe you're just doing it passively. You're doing division right here. How many times can 5 go into 20? Well, it can go in 4 times, and evenly at that. And 5, well, how many times can 5 go into 5? Well, one time, and that's why we made one group. So we go ahead, we reduce our groups, we get our first group, our second group, our third group, and our fourth group. Remember, we made 4 groups of x's, and we get a y. That came from our last group. So we can make it look nicer, look more professional, like we know what we're doing, and write x to the 4th and y. Okay? Alright. Oh, and I guess we should bada bing, bada boom it. Okay. Alright, so, okay, so you get to the back page and maybe you're freaking out. Dear God, you know, this looks crazy. There's a subtraction sign in there, there's parentheses. Why is it that when I flip to the back, it always gets hard? It's okay. Calm down. This is no more complicated than what's above. We just need to look at it for what it is. And so how do we start with that? Well, we're going to do the same thing. We're just going to break it down based on how we know things multiply together. And this is going to be very long because realize we have x minus 8 right there, and it's to a power of 12. So how many x minus 8 should we have right there? Still 12 of them, right? It's no different as if, where did we have 12 of something before? No, we didn't. But the same way we had 14 x's, we can just have 12 x minus 8s. You know, it's just another expression. It looks more complicated, and, you know, it doesn't look as nice to do, but it's still just an expression, right? And if you want, you could even substitute that for a different variable to make it look nicer. But that's, you know, that's clever math tricks. We're not doing that here. So I have 12 x minus 8s, so, oh, this is going to be a pain. There's 1. Okay, I'm just going to make parentheses. 1, 2, 3, 4, 5, 6, 7, 8, 9, running out of room, 10, 11, 12. Okay. Right, so these are all x minus 8s. And, by the way, if you understood the pattern from the last question, you don't really need to do this. It doesn't quite matter what x minus 8 is or what your expression that's repeated is. All you need to think is that you have some expression repeated 12 times, and you're looking for the square root of it. And, by the way, pro tip, when we don't write the root number there, it's implied to be 2. And I know we've gone over that before. So, your real question is just, if you have 12 items being multiplied and you're looking to put it into groups of 2, how many of those groups can you make? So, nothing different here, it just looks more complicated. So, we're going to see that we can make a group of 2, group of 2, group of 2, group of 2, group of 2. Oh no, okay, my bad, sorry. Group of 2, and then these two will be a group of 2. Okay, so what are all my groups? I have 1, 2, 3, 4, 5, and 6. I have 6 groups. So I will have x minus 8, 2, 3, 4, 5, and 6. X minus 8s, right? 6 of them. I had 6 groups, so that's what I was able to pull out. Notice, did I have any remainders? Any oddballs that were left behind? No. Right, we're good to go. Oh, that was not nice. How'd that happen? There we go. That's pretty cool. Okay, cool. Alright. Stop. Okay, so we have 6 of those. Nothing was left behind. Our root goes away because nothing is left under it. And we now just have x minus 8. And we're going to write it shorthand. We're going to write to the power of 6 because we had 6 of them. And that makes sense because, again, going back to that basic question, if we had 12 of something and we were looking to make groups of 2, well, how many groups of 2 could I make with 12 of something? And you could make 6. Okay. Alright, same deal with this one. So now at this point, right, you could write all these out, but you should take advantage of the pattern. These numbers get very big, and the idea of math is that we exploit patterns. We take advantage of them to help us out. So I'll break this down a little bit. I'll break it down to things with exponents, but then we're going to use our pattern of division to start calculating this. So 64, I need to know what that breaks down into. Well, it's an 8 and an 8, and I know that 8s are going to have 3 2s in them. Okay, so that is 6 2s. So right here, I'm going to have a third root of -1, 2 to the power of 6, x to the power of 18, and y to the power of 7. So, right, remember that question, we're just making groups. So, we look at 2 to the power of 6, and we have 6 2's, so how many groups of 3 can we make? Well, we can make 2 groups of 3. So we'll pull out a 2 and another 2, because we could have made 2 groups with those 6. Likewise, we have 18 of our x. We want to make groups of 3. How many can I pull out? Well, I can make 6 groups with 18 of something, right? 6 groups of 3 of 18 of something, so I'll have 1, 2, 3, 4, 5, 6. 6 groups that ultimately came out, that were made from the 18. And then, now the y. Now this one, it might be a little bit trickier. How many groups can you make with 7 of something, right? Groups of 3, 7 of something. We can make 2 groups. But you notice, if we make those 2 groups, we've used up 6 y's. And so you're noticing, right? We have a y left over. Well, that's okay. It's just a remainder. It's going to get left behind in the root. So y to the power of 6, or I'm sorry, we pulled out 2 groups of y, effectively 6 y's. And so we're going to have a y and a y come out. And that means that that one y that was left over is going to be left behind. Okay, so we could make 2 groups out of 6 of those, and then the other one was left over. Alright, and remember the rule, so a odd root of a -1, it doesn't go imaginary, we can actually pull that out. So odd roots of negative numbers, they just come out. Odd roots of -1, they just come out. So we'll go ahead, make it look nicer. So we have 2 times 2, we'll calculate that and make it 4. And then we have 1, 2, 3, 4, 5, 6 x's, so x to the 6th, and y times y, well that's just y squared, and a root of y. And I should really be writing the root number, it's sloppy for me not to do that. And that's our final answer. That's what we get. We had some stuff left under the root, we also had a lot of stuff that came out of the root. Okay, very last problem. So, same deal. We want to think about this expressed as many things written out. So, we want to look at all the factors of it. I'm going to take 320, and I'm going to break it down into its factors. So 320, well, I see 32 times 10 in there, right? Just 32 and 10. And then we have 32, and you know, it's just what happens when you do a lot of math. You know that 32 is actually just 2 to the 5th. But say you didn't see that, you could always do 16 and 2. And that would totally work too. And you get 2 4s from 16. And each 4 is going to have a 2, or 2 2's. And 5 and 2. So how many of each thing do we have, right? We're going to be organized, and we're going to express things with exponents. So we have 1, 2, 3, 4, 5, 6 2's. So 2 to the power of 6. How many 5's do we have? We have just 1. And then we have x plus 1 to the power of 6. So we're still just going to write that. You could write it out all the way like we did earlier. But hopefully at this point you don't quite need to, right? So again, and you know, if you're still feeling weirded out by x plus 1, don't. It's just a term. We have 6 of them, and we're just looking to make groups with it. So as we go through this, we have 6 2's. We want to make groups of 3 out of them. So how many groups can we make? Well, we can make 2 of them. So we'll have a 2 and a 2 come out. We have 1 5. How many groups of 3 can we make with a single thing? Well, we can't. Right? So this 5 is going to get left behind. And we'll write that later. And I have x plus 1 to the power of 6, so I have 6 x plus 1s, or just 6 of these things. I want to make groups of 3. How many can I make? Well, again, I can make 2 of them, just like my 2's. So I'll have 2 of those guys out here. And then remember, I had my root 3, and my 5 was left over underneath it. Couldn't make anything with it. So dressing this guy up, making it look better, we are going to get 4 x plus 1 squared with a root 3 of 5. That is our final answer. Okay? I hope this is helpful. Good luck, guys. We are coming up on our quiz. We're going to have 3 sections of IXL on this quiz that's coming up, 2 of which are all right here. So think about it this way, you've already done 60% of what's going to be on our quiz that's going to come up next week. So hope you did great on the quiz today, and I look forward to seeing you when I get back. Take care.